All right, so get this. We're diving deep today into the world of thermometers.
Thermometers.
But not just any thermometers.
Yeah.
These are insanely precise.
Yeah.
And they use something called Rydberg atoms.
Okay.
Ever heard of those?
I have actually.
Yeah.
Yeah, they're really fascinating.
So basically, they're like atoms on steroids, right?
Yeah, you could think of them that way.
Right.
They're supersized atoms, incredibly sensitive to their surroundings.
Interesting.
Yeah, it's like imagine those inflatable dancing figures you see at car dealerships. You know,
Oh, yeah.
big and floppy,
Ah,
easily swayed by the slightest breeze.
right.
Rydberg atoms are kind of similar in that way.
Okay.
They're so big they react to even the tiniest changes in their environment.
So instead of mercury rising in a tube, we've got these giant atoms doing a little dance to tell us how hot or cold something is.
Exactly. And the breeze in this case is the heat radiation given off by everything around us.
Oh, wow.
And the swaying tells us the temperature.
I see. So the NIST article we're looking at today mentions that scientists actually created these Rydberg atoms by cooling rubidium atoms down to almost absolute zero
Right.
and then zapping them with lasers.
Yeah, that's key to their accuracy.
How so?
Well, because they're so big, they react to even the tiniest changes in blackbody radiation,
Okay.
which is that invisible heat given off by everything around us.
Okay, so things heat up, they emit more blackbody radiation, and these Rydberg atoms go wild.
Well, going wild might be a bit of an overstatement.
Okay.
But
Okay.
essentially, the electrons within the Rydberg atom get a boost from the heat and jump to higher energy levels. And by measuring these jumps, scientists could determine the temperature with remarkable precision.
So it's kind of mind-boggling to think that we can measure something as small as a temperature change by observing these tiny jumps in electron energy level.
It really is remarkable.
Yeah.
And it gets even more interesting when you consider the practical implications.
Oh, yeah. Like what?
Well, imagine trying to take the temperature of a jet engine while it's running.
Okay.
A regular thermometer wouldn't stand a chance.
Right.
But a Rydberg thermometer could do it from a safe distance.
So we're talking contactless temperature sensing?
Exactly.
That sounds like a game changer, especially in fields where traditional thermometers might be too dangerous or impractical to use.
Absolutely. And what's incredible is that this thermometer can accurately measure temperatures in the range we experience every day,
Really?
from 0 to 100 degrees Celsius.
So it's not just some theoretical concept, it has real-world applicability.
Precisely.
And speaking of real-world applications, the NIST article mentions something about this thermometer helping to improve atomic clocks.
Uh-huh.
How is that even possible?
Well, even the slightest variation in temperature can throw off the incredibly precise measurements of atomic clocks.
I see.
But by using a Rydberg atom thermometer to monitor and compensate for those tiny temperature changes, we could potentially make atomic clocks even more accurate.
Wow.
Yeah.
That's fascinating.
It is.
It's amazing to think that this thermometer could lead to better atomic clocks.
Yeah.
And then those better atomic clocks could lead to who knows what other advancements.
Exactly.
It's
Yeah.
a real chain reaction of accuracy.
It really highlights how everything's connected in science, you know?
It does.
Progress in one area can lead to advancements in a totally different field.
Absolutely. And speaking of advancements, the source material we're looking at today mentioned that this technology could be a real game changer for quantum computing.
That's right.
Can you tell us a little more about that?
Sure. Have you ever heard of quantum computing?
I've heard the term, but to be honest, it's a little over my head.
Yeah, it's a pretty complex topic, but essentially,
Yeah.
it's a revolutionary new type of computing
Okay.
that harnesses the laws of quantum mechanics.
Quantum mechanics.
Yeah, it's pretty wild stuff.
I bet.
But basically, quantum computers can solve problems that are impossible for traditional computers to handle.
Wow. So what makes them so different from the computers we use every day?
Well, traditional computers store information as bits,
Okay.
which can be either 0 or 1.
Right.
Quantum computers use qubits,
Wait.
which can be 0, 1, or both at the same time.
Both at the same time.
Yeah, it's called superposition.
Superposition.
And it allows quantum computers to perform multiple calculations simultaneously.
Okay, that already sounds complicated.
It is. It is.
But how does this new thermometer fit into all of this?
Well, quantum computers are incredibly sensitive to their environments,
I see.
especially temperature fluctuations.
Okay.
Even the slightest change in temperature can disrupt those delicate quantum states and cause errors.
So it's kind of like trying to build a house of cards in a hurricane.
Exactly, a very delicate process.
Yeah, so these Rydberg atom thermometers with their incredible accuracy and non-contact sensing capabilities could be used to monitor and control the temperature inside quantum computers, keeping those house of cards from collapsing.
Exactly like having the ultimate climate control system for these super-sensitive quantum machines.
So by maintaining those incredibly precise temperatures, these thermometers could help unlock the full potential of quantum computing.
That's the idea.
It's mind-blowing to think that something as simple as a thermometer could play such a crucial role in this cutting-edge field.
It's a great example of how advancements in one area of science can have a ripple effect across multiple disciplines.
For sure.
And quantum computing isn't the only area where this technology could have a significant impact.
Oh, right. The source material also mentioned applications in spacecraft and high-precision industries.
Exactly.
So let's shift gears for a moment and talk about those other applications.
Okay.
What kind of impact could we see in those areas?
Imagine using these Rydberg atom thermometers to monitor the temperature of sensitive components on a satellite.
Okay.
Out in space, temperatures can fluctuate wildly between the side facing the sun and the side in shadow. And unlike here on Earth, you can't exactly send a technician up there for a quick repair if something overheats.
Good point.
So having this kind of precise, non-contact temperature sensing could be invaluable for space exploration.
Makes sense. Reliable temperature control would be critical for ensuring the long-term functionality of those expensive and complex spacecraft.
Absolutely.
But what about applications here on Earth in those high-precision industries you mentioned?
Well, think about manufacturing processes that require incredibly fine temperature control, like producing microchips or pharmaceuticals.
Okay.
Even a tiny temperature variation can ruin an entire batch.
Yeah. It's like baking a cake, but a million times more complex.
Exactly.
And a million times more expensive if you mess it up.
Exactly. So having a thermometer that can provide instant accurate readings without interrupting the process could save huge amounts of time and money.
Time is money.
Exactly. And because it's contactless, there's no risk of contaminating sensitive materials.
So we're talking about increased efficiency, reduced waste, and ultimately better products across a range of industries.
Precisely.
It's incredible to think about the broad reach of this technology.
It really is, and we're only just scratching the surface.
I imagine.
As scientists and engineers continue to explore the capabilities of these Rydberg atom thermometers, we can expect to see even more innovative applications emerge in the years to come.
Wow. It seems like we've only just scratched the surface of what this Rydberg atom thermometer can do.
Yeah, it really makes you think.
I mean, measuring temperature is so basic.
Right.
But this new technology has such far-reaching implications.
Absolutely. It's a testament to the power of just basic scientific curiosity, you know?
Yeah.
Sometimes the biggest breakthroughs come from pursuing something just because it's interesting.
Totally.
Even if you don't know what the practical applications might be.
Yeah, and in this case, that curiosity has led to something incredible.
For sure.
A tool that could revolutionize all kinds of industries.
From space exploration to quantum computing.
It's pretty mind-blowing.
It is.
It makes you wonder what other basic measurements might be revolutionized in the future.
That's a great question.
I mean, if we can measure temperature this accurately using these giant atoms, what's next?
Right. What if we could use a similar approach to measure pressure?
Oh, wow.
With atomic level accuracy.
That would be incredible.
Or maybe even detect tiny changes in gravitational fields.
Now you're talking.
Think about it.
I am.
Mapping the Earth's gravitational field in unprecedented detail.
Wow.
Studying the subtle variations in gravity around black holes and other celestial objects.
That would open up a whole new realm of scientific inquiry.
It would. And it's not just about measuring things we already know about with greater precision.
Right.
What if we could use Rydberg atoms to detect things we've never been able to measure before?
Oh, like what?
Well, some scientists believe these supersensitive atoms could even be used to search for dark matter.
Dark matter.
One of the biggest mysteries in the universe.
That's amazing.
We've been trying to detect it for decades.
Yeah.
But maybe these Rydberg atoms hold the key.
That's a tantalizing thought.
It is, and it highlights the fact that we're really just at the beginning of exploring what's possible with this technology.
Yeah.
Who knows what other discoveries are out there waiting for us?
This whole deep dive has been a fantastic reminder that science is a journey of constant exploration and discovery.
It is.
What seems impossible today could be commonplace tomorrow.
That's the beauty of it.
It's so exciting.
If you're listening and feeling inspired, remember to stay curious.
Yeah.
Never stop asking questions.
Absolutely.
You never know what you might discover.
Well said. It's been a pleasure exploring the fascinating world of Rydberg atom thermometers with you today.
Likewise.
Thanks for joining us on this deep dive.
Thanks for having me.
And we'll see you next time for another exciting adventure into the realm of science and discovery.